Welcome back to my channel. Today, we will discuss about the graph of rational function, quarter 1, module 9. But before that, do not forget to subscribe and click the notification bell. The graph of a rational function. Given f of x is equal to ax minus b all over cx minus d. You have observed that both numerator and denominator are degree of 1. In this case, there are two possible graphs that we can sketch. In the first graph, so let us now observe the behavior of the graph, both sides of the vertical asymptotes. As the values of x are getting closer and closer to the vertical asymptote, the values of y are increasing without bound. On the other side, it must be opposite direction. As the values of x are getting closer and closer to the vertical asymptote, the values of y are decreasing without bound. The second graph. Let us now observe again the behavior of the graph, both sides of the vertical asymptotes. As the values of x are getting closer and closer to the vertical asymptote, the values of y are decreasing without bound. On the other hand, you have observed that as the values of x are getting closer and closer to the vertical asymptote, the values of y are increasing without bound. In sketching the graph of a rational function, it is easier for us to sketch if we know the y-intercept, x-intercept, the vertical asymptote, and the horizontal asymptote. Let f of x is equal to x minus 8 all over 2x plus 2. Find y-intercept, x-intercept, vertical asymptote, horizontal asymptote, and sketch the graph. First, we need to find the y-intercept. To find the y-intercept, we let x is equal to 0. From the given function, we will now substitute the value of x, which is 0. Then simplify, so we have negative 8 over 2. Then we can still simplify this, so we have f of 0 is equal to negative 4. Then, the y-intercept is 0, negative 4. Second, we need to find the x-intercept, so we let f of x is equal to 0. From the given function, so we will now substitute the value or f of x to 0. So we have 0 is equal to x minus 8 all over 2x plus 2. Then multiply both sides of our equation by the LCD. So since the LCD is 2x plus 2, then multiply both sides. Then we have 0 is equal to x minus 8 because 2x plus 2 times 0 is 0. Then x minus 8 all over 2x plus 2 times 2x plus 2, we can cancel out the common factor. Therefore, we have x minus 8. Then solve for x. So, transpose negative 8 on the other side. So, we have 8 is equal to x, or it is just the same as x is equal to 8. Therefore, the x-intercept is 8, 0. Then, the vertical asymptote. To find the vertical asymptote, always remember that we need the denominator of the given rational function. Since the denominator is 2x plus 2, we will equate this to 0. Then solve for x. So transpose positive 2 on the other side. So we have 2x is equal to negative 2. Then divide both sides by the coefficient of x, which is positive 2. So we will now divide both sides of our equation by positive 2. So we have x is equal to negative 1. Therefore, the vertical asymptote is x is equal to -1. Then, the horizontal asymptote. To find the horizontal asymptote, if you can still recall that we only need is the leading coefficient of the numerator and the leading coefficient of the denominator. Since both numerator and denominator, they have the same degree. So, the horizontal asymptote is y is equal to a over c. Then substitute the values of a and c. So we have y is equal to 1 over 2. Therefore, the horizontal asymptote is y is equal to 1/2. Let us now sketch the graph of the given rational function. In sketching the graph, we must plot first the x and y intercepts. So since the y-intercept is 0, -4, so let us now plot this. Then the x-intercept is 8, 0, and we must sketch first the horizontal and vertical asymptotes. So since the vertical asymptote is x is equal to -1, and the horizontal asymptote is y is equal to 1/2. Now, let us now connect the x and y intercepts. Since you have observed that both both intercepts are in the right side of the vertical asymptote. So let us now connect. Now, in this case, you have observed that as the values of x are getting closer and closer to the vertical asymptote, the values of y are decreasing without bound. Therefore, on the other side of the vertical asymptote must be the opposite. So, as the values of x are getting closer and closer to the vertical asymptote, the values of y must be increasing without bound. So let us now sketch the behavior of the graph. So this is just an opposite graph of the first graph that we already sketched. Let us now use another function. So g of x is equal to 3x plus 9 all over x minus 3. Find the following and sketch the graph. So let us now find the y-intercept. We let x is equal to 0. Then substitute to the given function. So we have g of 0. Then simplify. So we have 9 over -3. Since we can still simplify this, therefore g of 0 is equal to -3. So the y-intercept is 0, -3. The x-intercept will let g of x is equal to 0. Then substitute the value of g of x to the given function. So we have 0 is equal to 3x plus 9 all over x minus 3. Then multiply both sides of the given equation, or multiply both sides by x minus 3. So we have 0 is equal to 3x plus 9. Then transpose 3x on the other side of our equation. So we have -3x is equal to 9. Then divide both sides by the coefficient of x, which is -3. So we have x is equal to -3. Therefore, the x-intercept is -3, 0. The vertical asymptote. So since the denominator is x minus 3, we will equate this to 0. Then x is equal to 3. So this is now the equation of the vertical asymptote. So vertical asymptote is x is equal to 3. Then the horizontal asymptote. So since both numerator and denominator are first degree polynomial functions, then we will use y is equal to a over c. Therefore, y is equal to 3 over 1, and that is y is equal to 3. Then, the horizontal asymptote, or the equation of the line, is y is equal to 3. Let us now sketch the graph of g of x. Since we already have the y-intercept, so let us now plot this. Since the y-intercept is 0, negative 3, and the x-intercept is negative 3, 0, then let us now sketch the vertical asymptote with the equation of x is equal to 3, and the horizontal asymptote with the equation of y is equal to 3. Then let us now connect the x and y intercepts. So you have observed that the behavior of the graph from the left side of the vertical asymptote, as the values of x are getting closer and closer to the vertical asymptote, the values of y are decreasing without bound. Therefore, the behavior of the graph from the right side of the vertical asymptote must be opposite, as the values of x are getting closer and closer to the vertical asymptote, the values of y are increasing without bound. So it looks like this. So this is now the graph of g of x is equal to 3x plus 9 all over x minus 3.